lot to do today, so what I did is I printed off the notes for you. Okay, I actually just printed off the notes in Notebook, and I gave them to you. That way you guys don't have to spend all your time writing stuff down. I need you to follow along for your notebook. This is chapter 2, section 5. This is linear regression. Okay? Linear regression, that's what the chapter of the title of the section is called.
Will this be the first thing we need in our notebook for the...
Yes.
For like, so we can print it out?
Not yet.
Oh.
Linear regression is a linear equation that gives an accurate model to do predictions into the future given a set of data. Okay, now what the heck does that mean? Well, what's linear mean, first of all? A line, right? Have you guys ever heard of people predicting the population in year 2050?
Yeah.
Yeah.
Yeah, they do it all the time, don't they? Do you think they just make this stuff up?
No.
No, they use data, and they come up with a good formula, and then they predict the future. Well, guess what? You're going to learn how to do that today. Okay? You would be able to predict the future of the population given what we're going to do today. Okay? So, that's what that means. They're going to take the future, or the past data. So you could go back to 1900, 1910, 1920. You could find the population in the United States, and you could write all that stuff down for every single year, right? And based on that information, you could make a logical guess at what it's going to be in 2050. Okay? You could do that. And when you see what we're going to do today, you're going to see how. Okay? But that's what linear regression is. Now, today we're talking about linear regression. There are tons of different regression models. There are lots of. Okay? Here's a list of all the regression models. Okay? Linear is the one we're talking about today. We're just grazing the statistics. We're just talking about the straight line. Okay? We can talk about quadratics, which looks like a U. Okay? There's a line, there's a quadratic, which is x squared. You get 4x squared plus 3. Okay? That's quadratics. An exponential is going to be x cubed, x to the 4th, x to the 5th, all that kind of stuff. That's an exponential function. Okay? Logarithmic has either the natural log or log. Some of you may or may not have heard of that before. It's okay if you haven't. We haven't talked about it yet. Okay? I don't even know how to pronounce this one. Okay, but I do know what it looks like. Have you ever seen a chart for somebody's heartbeat? Right? Yeah, it looks like this. Like, right? Are you with me? Right, I mean, I don't know. It looks something like that.
Yeah.
You with me? With heartbeat, it looks something like that. And then you have your earthquake graph, which looks like this. You're going to have little, big, little, and I get big again. That's how they determine, okay, how big the earthquake. What's that?
It's a lie detector graph.
The lie detector graph, that could be that too, but that's a type of graph.
Yeah.
Okay? That's how they determine how big an earthquake is. It depends how high it hits on the Richter scale. So this is a 10, that means those lines went all the way up to 10. Okay, 5 or whatever. That's how they determine how bad an earthquake is based on how the graph looks. Okay, it was a Richter scale, says it was a 5. That means it was right in the middle. It was pretty bad. If you get a 10, everybody's probably dead. Okay? That means it was terrible. I know. All right. Let's keep going. Correlation. Correlation is determined by the R value, okay, of a regression model. So we're using a linear regression today. So based on the R value, the closer the R value is to 1, the more accurate your regression model is. So if you're doing statistics, okay, you want to find some data, okay, and you did a regression model and your R value was not close to 1. That means your model probably isn't very good. Okay, but if it's really close to 1, it's like 0.997. It's going to be somewhere between 0 and 1. It's like 0.997. That means you've got a pretty good estimation of the future. Okay, it means your graph, your data is pretty good. Okay, the relationship between the two is good. Okay, it's based on the R value. You can have two main different types of slope in your correlation. You can have a positive correlation where the slope of the line that fits the data is positive. Okay? For example, population. Over time, is the population going up or is the population going down? It's going up for the most part. Huh? We'll talk about the population in China. Is it going up or down?
Down.
Population in China is going down?
No, up.
China is getting too big. Okay? It's going up by the hundreds of thousands. Okay? Population, for the most part, is going up. Places are filling up. Okay? Population's going up over time. In the year 2000, whatever, 30, we're going to have a bigger population than we do now, for the most part. Okay? Now, that would be positive correlation. Negative correlation could be maybe the number of elephants in the world. Okay? We go back to like 1700, how many elephants were here in the world? Yeah, there were quite a few. Now if we go today, how many are in there? There's not very many elephants left. Okay? You see the negative correlation? It's going down. Over time, it's going down. We're losing elephants for the most part. Okay? So that's positive and negative correlation. Strong correlation and weak correlation. Okay, so if I tell you, give me the correlation, you're going to say strong positive, weak negative, strong negative, weak positive, whatever. You're going to use those two words. Okay? Now, strong is when your R value, okay, is very close to 1. It's like 0.963, point whatever. It's very close to 1. Weak correlation is when it's like 0.7. That's not very close. Okay, we're looking at numbers between 0 and 1. Okay, you want to get close to 1 as you possibly can. Okay, the closer it is to 1, the stronger your line, the stronger your correlation. Do you understand? R doesn't mean much to you right now. It will in just a minute. Okay, once we go through this. Do we have any questions on the notes so far? We'll go over the page. This is what they look like. When you make a scatter plot, basically you have a bunch of points, and you're just plotting some points based on the information you were given. You did some research on the number of, in the year 1900, the number of giraffes, or the number of elephants, whatever we were talking about. The number of elephants was 100. Then you went to the year 1910, the number of elephants was 50. And you went to today, and we only have 5 elephants left. That's not correct. Do you understand? That's what the points stand for. Okay? Now, do you see what they look like when there's a strong negative correlation? All the points are clustered really close to that line. The cluster is really close. That means it's strong. That means your R value is really close to 1. When you see how the points are more scattered for the weak negative correlation? They're scattered. They're not as close. That means it's weak, but it's still negative because it's going down. No correlations is when there's no relationship. And you might say, somebody in 7th period asked, well, when do you have no correlation? Well, like, it's when the number of years has nothing to do with whatever you're measuring. For example, the number of red cars over time. Okay, does it have anything to do with time and how many red cars we have? You might have had tons of red cars in 1990 and then not so many in 91. And you had a lot more in 92, and then the number of red cars went down. I mean, it may be a little bit of correlation, but you see how there's really not much of a correlation. Or the number of blue shirts in my classroom in the year 1990. Okay, and the number of blue shirts in 1991. You see how there's no relationship really, as opposed to population where there's a relationship in time and years. There's not going to be much of a relationship in that. Does that make sense? No correlation is just going to be dots all over the place because it doesn't really matter. There's no relationship. Then we have positive, strong positive, and weak positive. Close to the line, spread apart. That's what you're going to look like here. Okay? Questions? Now we're going to take all this information that I just threw at you, and we're going to do a problem of like what you're going to do in your homework tonight. Okay? I'm going to use the Inspire calculator. Now, obviously, you don't have Inspire calculators at home. This would be the time where you could really use an Inspire calculator at your house. Okay? I'm not going to make you buy it. Okay? But if you want one, right now is the time where you could use it. Okay? Because you're only going to be able to do your homework in class. If you don't get it done, you have to find time to come get an Inspire calculator. Okay? Question?
I saw one at the pawn shop for $80.
There you go. Pawn shop, $80. It was in the box still? There you go. Pretty good deal.
It's a waste of $80. I use that for the car.
Alright. So here's what we're going to talk about today. I went back. I didn't really. I actually pulled this information from somewhere. But apparently it's accurate data because it came from the U.S. Department of Agriculture. Okay, and I found the cost of whole milk over time. Okay? Positive, negative, or no correlation. What do you think? Yeah, it's going to be positive. It's going to go up. Cost of milk is going up. I mean, back in 1980, you probably paid 80 cents per gallon of milk. Whatever. I don't know. Okay, but in 1998, the average cost per gallon of whole milk was $2.65. And then in 2000, $2.89, $3, $3.01, $3.20, $3.77. You see how it's going up? For the most part, as time goes on, it's pretty much going up. Okay? Now, we're going to graph it. Then we're going to do three things. We're going to graph points. Okay? The first thing we're going to do, I'm going to make it blue, because that's what I do for my glasses. Okay? We're going to make a movable line. Okay? We're going to just draw a line. Step two, or the other type of line you're going to make, is you're going to give me the equation of a line given 2 points. And the third thing is going to be your regression line. So you're going to have, on every single graph, you're going to have 3 different lines. For your homework tonight, you're going to have to do 1 and 2. You're going to have to make a movable line, or just make a line that you think looks, you can eyeball it and it fits the best. And you're also going to have to pick 2 points, and you're going to have to make an equation that you think would work. Okay? Those are the 2 you have to do. Obviously, you can't do regression, because regression you need an Inspire calculator. We're going to do that tomorrow in class. Okay? Any questions? What we're going to do? So what you have to do 1 and 2. So when I do 1 and 2 here, you really need to pay attention. Okay? When I do 1 and 2, you have to pay attention, because you're going to have to do that for homework. Okay? Now, I'm going to start. I'm going to do everything on the TI Inspire calculator, but everything I do for 1 and 2, you can do on paper, and you're going to have to do tonight. Okay? So you can do it on paper. If you want to grab the Inspire calculator sitting at your desk in front and follow along here, you're going to have to do it tomorrow anyway, so you can kind of get an idea of what buttons to push, and if you don't, that's fine. I don't care. The Inspire calculators are just there for you if you want to use them. Now, I'm going to start at a blank page, and we're doing data and statistics, and I want a data and statistics chart, so I clicked on data and statistics. Now, it would plot those points for me. At year 1998, it was, what, 2-something, 260-something?
265.
265, but it doesn't know what to plot, right? I don't have any information in there. I need to put the information in there so it can plot the points. How do I do that? Well, here's how I do that. I'm going to add a page, and I'm going to add a list and spreadsheet. I'm going to add a page where I can put the information. Okay? So I'm going to put it in a spreadsheet. I'm going to put the year in for X. I want the year to be X. Anytime you have years or time, you always want time to be your X value. Okay? Does that make sense? We'll talk about that in just a minute. So what years do I have? I have 1998, 2000.
2002.
Right. Now here's the problem. Now let me show you what's going to happen. I could put those in and show you, but I don't want to do that because it'll take too much time. I want to show you. Okay? It's going to plot the points, okay, on my table here. And it's going to start, and I told you I want X to be what? I want X to be the time, right? I want X to be 1998, I want X to be 2000, those things. So this is the X part of the graph, right? Now, if I put in 1998, where is that on this line? Where's 1998 on this line? 1,998.
It's going to start at 0, 6, and 3.
Yeah, this is 0. It's going to be like completely out here somewhere, 1998, right? It's going to be like off in La La Land, and then it's going to be 2000. So my information is going to be way out here in La La Land. Do you see that? I don't want that. I want my information to be in this spot right here. How in the world can I bring that information and put it in here? Change your value. Change your X value. Okay? So what I'm going to do is I'm going to look here and I'm going to say, okay, 1998. I'm going to make up my own year 0. I'm going to say, okay, I'm going to pick something that's similar. I'm going to say, okay, I'm going to make 1990 year 0. So year 1 would be 1991, right? Year 2 would be 1992. Year 3 would be 1993. So what's 1998?
8.
Year 8. What about 2000?
10.
12.
Right?
Yeah.
Now when I go and plot these points, they're going to be right in here. That's what you want. I don't want points out here in no man's land. That's hard to figure out. I'm going to make up my own year 0. I'm going to go back to time and I'm going to make up, okay, I'm going to make up year 0 and I'm going to make up year 1 and year 2. That way I can have my data be in this red box. Okay? You need to know how to do that for your homework. Okay? You need to know how to do that. You make up your own time, label it, and then you plot it in. Okay? Any questions on that? That's a little hard to understand if you didn't follow along there. Okay. So now I have my time figured out. Okay? So now I'm going to go back into my spreadsheet and I'm going to plug in my X values. Well, I had year 8, year 10, year 12, year 14, year 16, and that's as far as I want, or did I go to 18? 18? Okay, and then I had to put in the values that Y was. I want Y to be my cost. So I'm going to name it cost. And what cost was $265.
$3, $3.11, $3.20, $3.77.
Right? So far so good. So I have the information. I took my table basically and just put it into the Inspire so that I had somewhere to draw my information. So I'm going to go back over to my line and I'm saying, okay, right now it doesn't know what's going on. Okay, so I'm going to tell it. Remember what I told you, what do I want X to be always? Time. So I'm going to go down here to my variable. Which one of these is time? Cost or, I told it what it's going to be, cost or year. Which one do I want?
Year.
Year. Because that's my time. Now, what do I want this way to be?
Cost.
Cost. And it plots it for me. Isn't that awesome? Today, on your homework, you're actually going to have to do this by hand the old-fashioned way, the way we used to do it when I was in high school. We didn't have a nice, cool little TI Inspire to plot it all for us. Okay, we had 84, but it wasn't quite that cool. Okay? You're going to actually be given points you have to plot. Okay? Just go to up your X value, go up your Y value, make points. That's what you're going to have to do. It does it for me. If you have an Inspire, I'd let you do it in your Inspire, but nobody in here has one, do they? Does anybody have one yet? If you have it and you want to do it on your Inspire, you get one tonight and you want to do your homework in Inspire, just save your document and I'll accept that as homework. Okay? You don't have to do anything on your paper, but since you don't have Inspire, they have to make you do it on paper. Okay?
Download it and fire on my computer, can you do it?
As long as you have a way to get it to me. Okay? You have a way to get it to me. Now, any questions on how to do this? We have our information there. Now, remember those 3 types of lines I told you you're going to have to draw? The first line, did you write that down? What's the first type of line you're going to do it for your homework? Move line. You're just going to make up a line that looks like it fits. Okay, you're going to look at the information, the dots. Okay, your scatter plot. You're going to say, okay, I'm going to put a line in here that I think would be the best line for this information. Okay, so I'm going to go ahead and put menu, analyze, add a movable line. And it put a line in there that I can move around. So I'm going to move it to how I think it's going to fit. I think that's pretty close. Yeah? Pretty close? Now, I made that one on my smartboard. I made that, what, blue? So I'm going to make that. You can't do this on your calculation for class, but this one I can. Okay. Do you see what the equation of the line, of the movable line that I made? The slope is 0.098, and the y-intercept is 1.865. That's the one that I made. I made it up. Okay? So tomorrow, if I tell you, in their Inspire calculators, you're going to put in the information, the dots. I'm going to say, what's the equation of your movable line? You're going to click on the movable line. Okay, if you click off, the equation goes away. But if you want to see the equation, I ask you for it, all you have to do is click on the line and write down in mx plus, you're going to say y equals, or m of 1 of x, that means movable line 1, equals 0.0949x, that's your slope. And there's your y-intercept. You're going to write that down. That's your movable line equation. Everybody's is going to be different. Some of you might have a different slope. Some of you might have a different y-intercept, but you pick the line that you think best fits. Okay? Does that make sense? On your homework for today, you're going to plot your points You're going to grab a ruler or a straight edge, and you're just going to draw a line. You don't need to put the equation in. I just want you to draw a line. You can do it in different color if you want, so you know which ones are movable. Put it on there in your homework, okay? That way tomorrow when I say put a movable line in, you have some idea of what I mean, okay? Now, you're also going to have to do step 2. Give the equation of the line given 2 points. So I'm going to go back over to my notes page, okay? And I'm going to look at my points here. I have 8, 265, 10, 289, 12, 3, 14, 301, 16, 320, and 18, 377. If I look at those, which 2 points, which gray points here, pick 2 that you think if you went through a line through those 2 would be the best line to represent these points.
8, 12.
8 and 12? So he's saying, okay, maybe this one and this one, these 2 points right here. If you can draw a line through those 2 points, you think that's going to be a pretty good representation of the information? Sure. So let's go back to our page and let's do the algebra. So he picked 8 and 12. So I have 8, 265, and 12, $3. So let's write that down. 8, 265, and 12, $3. With me? All right. How do you find the equation of a line given 2 points? Slope. How do I find slope given 2 points? Yep. So I have 3 minus 265 over 12 minus 8. So it's going to give me 35.
Yeah,
0.35 over 4. What's 0.35 divided by 4? 0.35 divided by 4. 0.0875. You with me? So that's my slope. So what do I do next? Sure, you can use y equals mx plus b, or you can use y minus y1 equals m times x minus x1. So I have 0.875 for my slope, or 0.0875, excuse me. X plus b, and I take which point would you rather use? Which was going to be an easier algebra?
12 and 3.
Yeah, 12 and 3. So I'm going to put in 12, I'm sorry. X stands for,
Y is
so 3 equals 0.0875, 12 plus b. Now we can find the y-intercept. So let's do that. 12 times 0.875, give me your calculator. 0.875 times 12. 1.05, right? So I'm going to subtract 1.05 from both sides. You guys can do that in your head. If you have $3 and you subtract $1.05, $1.95, right? So $1 would be 2, and then 5 cents would be $1.95, right? So 1.95. So what is the equation of my line? You with me?
No.
There's my slope that I found in the beginning, and there's my y-intercept. Slope, we found in the beginning, y2 minus y1 over x2 minus x1. We got 0.875. I plugged them in and got 1.95. I plugged in 0.875. I plugged in 195. That's how I got it. Okay? Now, I need to make that equation. I need to put it in my inspire. So remember that, so I don't have to split back and forth. You guys have it written down? Somebody have it written down? Okay. Here's how I do it. I'm going to go menu, analyze. I'm going to add or plot a function. Okay, so function 1 is going to be that line. Y equals, what was it, 0.0875x plus 1.95? And there it is. Does it go through those 2 points that we were talking about? 8 and 12?
Yeah.
Heck yeah, it does. Great. So let's make that one, I'll make it green. So that you can see line 2, color, line color, green. Okay, the equation of that line, there it is. That's exactly what we plugged in. So they're pretty close together, right? The lines, they're pretty similar. Now, here comes the third line that you're going to do tomorrow, is the regression line. This one's probably the easiest of the 3. Well, the movable line's pretty easy, but all you have to do is click Menu, Analyze. Do you see anything that you could get a regression line? Yeah, regression in 6. And then, what regression line do I want? Yeah, I could do a plus bx, but we haven't talked about that at all. That's statistics stuff. We want the one we are familiar with, the slope and the y-intercept. So we're going to click mx plus b, and there it is. Do you see how close it is to my green line? You guys are really adjusting the points. Yeah, let me make it red, and then you can tell, you can see the difference. Nope, that's my green one. You see that black one in there?
No.
I'll make it red so you can tell the difference. There you go. You have your red one, your green one, and your blue one. So they're all pretty close. Actually, your green one that we chose, the 2 points that we chose, that's pretty darn close to regression line. Okay? Now you might say, okay, I might ask you, okay, is this strong correlation or weak correlation? You say, well, what's the R value? Remember? You have to know if the R value is close to 1 to know if it's strong or weak. Based on looking at the picture, do you think it's strong or weak?
Weak.
You think it's weak? Well, let's look. Now, how in the world do I find out what the R value is? Well, let me show you. Okay? I'm going to go add a calculator page. And I want to go to Menu, Statistics, and we're going to make that line of linear regression. Okay? I'm going to make that linear regression. What is my X value again?
Your cost. I don't know.
Year. I wanted to know what those all were, but anyway. I want to save it to equation f of 2, because we already have an f of 1. We put that in when we found the equation with 2 points, so this is function number 2. Okay? And then, I don't think I want anything with that. I don't think. Include category. And there it is. There is the equation of your line. If you look at your M, what's the slope of that regression line? 0.0934929. That's the slope. Your y-intercept is 1.8721. What's my R?
Close to 1.
It's pretty close to 1. Now, it's 0.91. If it'd be 0.99, I'd be much happier. But it's actually, if you put strong correlation, I'd be okay with that, because it's 0.9. Okay? It could be weak because it's pretty close to below 0.9. Okay? But it's pretty close to 1, so I'd say strong. It's between weak and strong, but I'd say strong. More towards the strong. Okay? Now, I want to predict the cost of milk in the year 2020. Okay? I want to predict the cost of milk in the year 2020. How in the world do I do that? So up here, on my table, I want the year 2020. What year is that going to be for me?
20.
No, it's going to be 30.
It's going to be 30. I want to know what this is going to be based on my regression line. Okay? So if I ask you to make a prediction, this is how they make a population prediction. Okay? This is how they make a population prediction. Okay. Yeah, here's how they make a prediction. I'm going to go back over to my calculator. Oh, I thought it was. Well, there it is. Okay. Now, do you remember what I told you this function is? Remember we said this is function, what? Which function is it? And I can, if you don't know which function it is, you can actually scroll over. Which function did I make this? F of 2. So I'm going to go down here. I'm going to put F of 2. It recognizes it because it turned bold. It says, oh, that's the regression equation. That's what the calculator is thinking. I'm talking out loud for the calculator. Okay, and then what year were we going to put in? Not 20,
30.
30. What do you think the price of milk is going to be?
On $4.50.
Pretty good guess. $4.67
I'm
in the
sorry,
year
I'll go
2020.
thirsty if milk's the only thing to
Yeah.
drink. I'm paying $5 for a gallon.
Yeah, got
Goat
it.
milk.
Based on the past information, hang on just a second. Based on the past information, they're saying in the year 2020, guys, if everything keeps going up the way it's been going up, a gallon of milk is going to be $4.67.
I'm gonna buy my own cow.
You're going to buy your own cow. Question.
My dad's in Canada right now.
Uh-huh.
Gallon of milk is $13.
$13 in Canada. That is expensive.
In Norway, gas is $9.50 gallon.
In Norway, gas is $9.50.
See, I think we're paying too much.
Okay,
Last
Yeah.
tomorrow,
$3.
listen, today on your homework, you're going to have to plot points on your actual paper. You're going to have to make a movable line. Then you're going to have to make an equation of a line given 2 points. You don't have to graph that line. I just want you to come up with the equation. That way tomorrow when I give you the Inspire, you can actually plug it in. You don't have to spend all that time figuring it out. Okay, you're going to plug in, and then tomorrow for homework, you're going to have each one of these. You're going to take your homework from tonight, and you're going to put it onto the Inspire, and you're going to make a regression line, and you're going to write all that information down and see how you were on your homework. See if you were right. Does that make
How
sense?
can you really be wrong on it, though? Because all you're doing is...
Regression lines should all be the same. The other two don't necessarily have to be the same.